Hello.
How are you this evening?
I'm pretty good. How about you?
Good. So what are we tackling tonight?
Not too much actually.
Okay.
I might actually only have half an hour's worth of stuff, but
That's fine.
We'll see when we get to that point. Let's see. What do we? Hold on. Let me find my notes. So we've been doing properties of exponents.
Okay.
And some of them I understand, but it's hard to do them without a calculator, and that's the part where I struggle.
Give me an example.
Okay, one second.
Like this?
I've got a bunch of them here.
8 to the 2
yeah, that could be one of them.
Okay. This you can do without a calculator. Always do the bottom first. So we take the cube root of 8, which is 2, and then we square it. So that's equal to 4. And all the ones you're getting at this level of math are going to be perfect numbers like this.
Okay.
Most likely, at least. I don't know. Why don't you give me some of the problems you have, and we'll see.
Okay. Let's see. So, parentheses 64 divided, or 80 over 81, and then close parentheses, and then to an exponent of 2/3.
Okay. What's important to realize is that a over b to x is equal to a to the x over b to the x. So that's the situation we have here. In other words, I can take the quotient to an exponent is equal to the numerator to the exponent divided by the denominator to the exponent.
Okay.
Now let's solve both of these separately. What's the numerator? What's the cube root of 64?
Wait, is the cube root just 64 divided by 3, or?
No, it's what number multiplied 3 times together equals 64.
Oh, okay, yeah. I'd have to think about that one.
Well, it's 4. 4 times 4 times 4 is 64.
Okay. Is there a trick for doing that, or do you just have to know them?
It's good to memorize perfect square numbers and perfect cube numbers up to a point. Perfect square numbers, 1, 4, 9, 16, 25, 36. You should recognize these numbers. These are perfect square numbers. Okay? Well, what are perfect cube numbers? 1, 8, 27, 64, 125. That's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. And that's the best way to recognize how to take the cube root of 64 if you don't have a calculator. Well, first of all, recognize that it's going to be a whole number most of the time. Now, which leads us to this problem right here. I'm not sure what they're after here. I may have to think about this a little bit. Well, first of all, 64 to the 2/3 is 4 squared, so it's 16.
Right.
So now we got 16 over 81 to the 2/3. Now, the
So,
problem is that the cube root of 81 is not a nice round number.
oh wait, yeah, actually, it's meant to just be 8. Sorry, I forgot. She told us to cross that out, the 1.
That makes a lot more sense. Because now, what is 8 to the 2/3?
Well, is the cube of 8 2?
Uh-huh.
Okay, so then it's 4.
Okay.
So 16/4.
Or 4. You want to reduce it all the way, for sure.
Right. Okay. Let's see. So then they get pretty intricate.
Okay, but I'll bet they're all whole numbers still. They're not going to ask it
yeah.
otherwise.
Let's see. So
That's why I was puzzled by the 81. What is that doing there? Okay.
5x to the 4th.
All in parentheses like this, or
no parentheses.
no parentheses? Okay, because it has a different meaning. Okay.
5x to the 4th, and then y to the 5th, all over 30x to the 10th, and y to the negative 4th.
Okay. Let's do the numbers first. What is 5 over 30?
5 over 30 is it's 6.
Okay. We don't need the 1. What is x to the 4th divided by x to the 10th?
X to the 4th divided by x.
We're doing division, so we want to do subtraction, one level less, with the exponents.
Oh. Is that like a trick or something, or?
Well, it's the way I remember it.
Wait.
In other words, there's only 3 things to do with exponents. If you're multiplying the base, you add the exponents. If you're dividing the bases, you subtract the exponents. And if you're exponentiating the bases, like this, you multiply the exponents. So that's it. Between those 3 rules, you can handle every one of these problems. So what's x to the 4th divided by x to the 10th?
That'd be negative 6.
And it goes there for the moment. I say for the moment because usually they have instructions here saying don't leave any negative exponents in your answer. Right?
Mm-hmm.
Okay, so we're going to. We will adjust that. What about the y?
Okay.
Doing division again.
Right, so then we're going to subtract the exponents. So it's 1.
What is 5 minus a minus 4?
Oh, it's 9 then.
Again, goes there. So that's our answer, but it's got a negative exponent in it. How do we change that x to the minus 6 to be positive? Put it on the other side of the fraction bar.
Okay, yeah. I think she calls it the upstairs, downstairs, or...
Yeah. In other words, any time you have a negative exponent, it has nothing to do with negative numbers. If I say 3 to the minus 4th, that is 1 over 3 to the positive 4th. And, in fact, if I say 1 over 3 to the minus 4th, that's the same as 3 to the 4th. So the negative exponent only has one meaning. It means the reciprocal.
Okay.
Okay?
Mm-hmm.
So anytime you have a negative exponent, you can just move the whole thing to the other side of the fraction bar and turn it positive. Whether it's in the denominator or the numerator to start with, doesn't matter.
Okay. So we'll do another one like that. 8x to the 12th, and then y to the negative 3rd, all over 4x to the 7th and y to the y squared.
Okay. It's the number part.
Okay, so the number part is 2.
What's the x part? And
X
I find the easiest way to do these is to always end up in the numerator, and then if you end up with a negative exponent, move it. But don't try to figure out whether it's going to be in the numerator or denominator right away.
Okay, this would be 5.
X to the 5th in the numerator.
Wait, so what tells you that it's in the numerator? It doesn't.
Always in the numerator.
Okay.
In other words, even this one, y to the minus 3 over y to the 2, use your rules. That's going to be y to what?
This could be -1.
No. What's minus 3 minus 2?
Oh yeah, it's 5.
What kind of 5?
Positive 5.
No.
Oh. Wait.
Thomas, you really need to learn how to add and subtract positive and negative numbers, because that's what all of this is. In other words, if I have a minus 3 and I subtract a positive 2, that's minus 5. Okay? And it goes in the numerator for the moment. So it would be this. But then, now you make the change. In other words, all your answers are in the numerator until you get to the end. And then, how do I change that so that I don't have any negative exponents?
No, we move the y to the -5th below.
Well, and we change it to a positive 5. Yeah.
Right.
Like that. Yeah. Okay. That's really all there is to any of these. You're either going to add exponents if you're multiplying, you're going to subtract them if you're dividing, and you're going to multiply the exponents only if you're exponentiating, which is what it's called if I take b to the x and then take that whole thing to the y. That would equal b to the x times y. Even without that parentheses, even that problem right there.
Okay.
Okay?
This next one it seems a little bit more complex.
Okay?
So there's big parentheses and then 12x to the 7th and then y to the -1st all over 3x to the 5th, and then y to the 2nd, and then close parentheses, and that's squared.
Okay. So now we have the exponentiation part. Because these are being taken to exponents, and then we're taking the whole thing to a further exponent, that's what is exponentiation.
Okay.
Okay?
And wait, what was the rule for that?
When you're exponentiating, you multiply the exponents. In other words, if I have 3 to the 4th power all raised to the 5th power, that's going to be the same as 3 to the 20th power.
Okay.
Okay?
Mm-hmm.
That's what's going on up here. So, we have a couple of things we could do. First thing that makes the most sense is let's reduce this 12/3.
Okay. So that would be 4.
Okay. Now, we can do two things. We can multiply this 2 by each of these exponents, leaving it in the numerator, and also multiply it by each of these exponents, leaving them in the denominator, and then we can reduce. Or we could reduce first and then square it.
Okay.
So I'm not sure what's the easiest. Let's do it both ways. First of all, we have to square the 4.
Wait, so the 2 doesn't apply to the numbers?
It does.
It only
It
applies to the
applies,
exponents?
no, it applies to everything inside the parentheses.
Oh, okay, that's where you.
So 4 squared is 16. Okay?
Okay.
Now, the first way I'm going to do it, I'm just going to act on the numerator. So the next term in the numerator is that, 2 times 7. The next
Yep.
term in the numerator is what?
2 times -1, which is
Yes.
-2.
Okay. And now I do the same thing in the denominator. I got x to the 10th, 2 times the 5, y to the 4th.
Okay.
Now let's reduce that. What happens to the x's?
Okay, so let's see. So this one is x to the 4th,
Okay.
and this one is y to the -6th.
Good. And then that's going to go down to 16x to the 4th over y to the 6th. So there's the answer they want. Okay? Now let's go back and do it a different way. I'll leave that answer there. Let's reduce inside before we square anything. So we've got 16, excuse me, we've got 4, x to the 7th over x to the 5th is x squared. Y to the -1 over y to the 2 is y to the -3. And then we're going to square this whole thing. Well, that's equal to 16 x to the 4th, y to the -6th, which is the same thing as what we got before. So we can do this in any order we want. We can do the inside first, reducing it, and then square it, or we can just apply the square to the numerator and also to the denominator.
Okay.
In the same way that if I said square this, what's that squared?
Wait.
Okay, first of all, the 2 applies to both the numerator and the denominator.
Okay, so then 4 over 9.
Exactly. But this is also the same thing as 2 squared over 3 squared.
Yeah.
Which is 4 over 9.
Okay. I was trying to get something more.
Yeah, no, it's very straightforward, and it's just those rules.
Okay. It's pretty easy then.
Yes, it is. There's really only 3 rules, and then knowing what negative exponents, how to represent negative exponents.
So then I'll definitely need to learn the perfect squares and the perfect cubes, because I don't really
Probably already know perfect squares, you just don't know that you know it. But, you know, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. Those are the perfect square numbers.
Okay, yeah.
Perfect cubes are a little different. You might not have learned those yet.
Okay. Well, I think that's it with these.
Okay.
I guess we can keep going over some, or maybe do some ACT math.
Okay. I got a bunch of ACT in here.
Okay.
Whatever you feel a need to do, we can do. Let's see. We've done ACT before, haven't we?
I think we've done some. Maybe we did SAT. Well, I took the SAT, and my scores that were the worst were definitely the math.
Okay.
Like everything else was pretty good.
Mm-hmm.
So I'm going to take it again, but I'll probably start working on the SAT as well with you.
Are you going to take the ACT again?
Yeah, well, I haven't taken the ACT,
Okay.
so I think that's my next one. So I'll probably
I
I'll do a
have
little of both. But
I have both. I have like 8 SAT tests and 8 ACT tests in my computer. So we've got no shortage of problems to work on.
okay,
They're not that different. The type math you saw on the SAT, you're going to see on the ACT. The biggest difference is the ACT has 4 trig questions on it.
oh,
Are you taking the ACT soon?
whenever the next one, I think it's April.
I think it is April, which is in a
April
month.
something, yeah.
Well, let's talk about that because it's a shame. Have you had much trig at all?
No.
Any?
I'm trying to think. What would be an example of it? SOHCAHTOA. Yeah, we have had that.
Okay. Well, let me write on this page all of the things that I know you're going to need to know for the ACT trig part.
Okay.
Not a lot. It's very, very basic trig. It's trig you've already learned. But let's just review it. What is the sine of theta?
Let's see. Well, we have the side. I'm gonna have to refresh my.
Okay, let me go over what this means. Sine means opposite over hypotenuse. So every O in this thing means opposite, not over. There's a little hidden over right there. There's a little hidden over right there, and there's a little hidden over right there. So sine means opposite over hypotenuse, in this case 4 over 5. Cosine means adjacent over hypotenuse. Well, there's always 2 adjacent sides to any angle. There's the 3 is adjacent and the 5 is adjacent. So when you see adjacent, they always mean the one that is not the hypotenuse. There's only one adjacent side that's not the hypotenuse, and that's the 3. Just like there's only one opposite side to that angle, and that's the 4. Okay, so what's the cosine of theta?
The cosine. So it's adjacent over hypotenuse. So 3 over 5?
Uh-huh. When you take trig functions of angles, you get numbers. Or more precisely, you get ratios. What is the tangent of theta?
The tangent would be, O is opposite, right?
Uh-huh.
Okay, so that would be 4 over 3.
Correct. Correct.
Okay.
And make sure when you remember SOHCAHTOA, it's not SOHCAHTOA. It's SOHCA. You kind of almost have to remember the pronunciation is ka because it's C-A-H, not C-O-H. Okay? So that covers sine, cosine, and tangent, which I tend to think of as the 3 main trig functions. Those are the ones on your calculator. But there's 3 other trig functions, which are cotangent, secant, and cosecant. Each of those 3 are the reciprocal of one of these. That's something else. Knowing SOHCAHTOA will probably get you 2 of the trig questions correct. 2 out of the 4. That's a lot. Okay, so this is huge to know right there. If you know nothing else about trig, know that part.
Okay.
Be able to tell what the sine of any angle is based on the dimensions. All right. the other thing that you probably are going to have to know for one question is what the reciprocals of these three are. Well, the easy one to remember is cotangent. Goes with tangent. So the tangent of theta is always equal to 1 over the cotangent of theta. So what would the cotangent of theta in my triangle be?
Wait, 1 over the
Just think of it's the reciprocal. So if the tangent was 4 over 3, what's the cotangent?
Oh, 3 over 4.
Yes. Okay. So if you can remember that the cotangent is the reciprocal of the tangent, then the only thing left to remember is, does the secant go with sine or does the cosecant go with sine? Because one of these is the secant and one of them is the cosecant. And the way you remember it is there is exactly one co in each pair. So this is secant and this is cosecant. There's the co in this pair. There's the co in this pair. And there's the co in that pair. Precisely one co. In other words, you know that secant is not going to be the reciprocal of sine because there's no co in that pair.
Okay.
Okay? So these three reciprocal relationships, but since they're reciprocal relationships, then that means that cosecant is 1 over sine also. And secant is 1 over cosine. And cotangent is 1 over tangent. So these 6 reciprocal relationships you want to memorize. But you really only have to memorize one. This one right here. Because you can figure out these 2. And once you know these 3, you know these 3. So I don't even memorize these. I wipe these from my memory. Always memorize as little as possible when you're trying to memorize stuff.
Mm-hmm.
I think, at least, that's the best way
Yeah.
to memorize stuff. Don't memorize stuff you don't need to memorize. In other words, I don't need to memorize that cosecant is 1 over sine. I can figure it out from looking. As long as I know sine is 1 over cosecant, then I can figure out the other part of it. And
Okay.
almost the last thing you need to know is this. Sine squared of theta plus cosine squared of theta always equals 1. Or sine squared of x means the same thing. Doesn't have to be theta. In other words, what I'm saying is the sine squared of 30 degrees plus the cosine squared of 30 degrees equals 1, or of 29 degrees. That still equals 1, or 72 degrees. That equals 1. No matter what angle I have, if I take the sine of that angle and square it, and add it to the cosine of that angle and square it, I'm going to get 1.
Okay.
That is called the Pythagorean identity. These are called reciprocal identities. These are called Pythagorean identities because notice it looks a little like the Pythagorean theorem. It's a squared plus b squared. The only other 2 identities that you're going to need to know probably, is this one. That's it. Everything you see on this page, if you have it memorized, you'll probably get at least 3 out of the 4 trig questions correct.
Okay.
Okay? Trig is very complicated, but they don't get complicated on the test. They get very, very basic. But if you didn't know any trig, you probably wouldn't get any of them. So you want to know a basic amount of trig. SAT has no trig on it, so you don't need to know any of it for the SAT. But the ACT has precisely 4 trig questions.
Okay.
Okay. The ACT also has 2 conic section questions. Conic sections are mainly circles and ellipses. And what they expect you to know is the equation of a circle and the equation of an ellipse, and that's it. Well, the equation of a circle that's at the origin is this. If I have a circle of radius 2, then the equation of this circle is x squared plus y squared equals 4, radius squared. That would be the equation of that circle. Okay?
Okay.
If I move it off the origin to some point h and k, then the equation becomes this. Very similar, only it's x minus h and y minus k. In other words, if I have my circle up here, not at the origin, but at a point 2, 3, then my equation is going to be x minus 2, the x-coordinate, plus y minus 3, the y-coordinate, still squared, and if the radius of that were 4, it would be 16. Of course, the radius...
So the first one, though, it isn't on a graph. I don't get that. Or is it?
The first one I did, yeah, it was a graph right there.
Oh, if it's on the origin.
If the center of the circle is at the origin, then h and k are both 0. So this becomes that. If I let h equal 0 and k equal 0, I merely have x squared plus y squared equals r squared. Okay? So this is the circle, and that's all you need to know about a circle, other than one other thing. Any point on this circle, on the circumference of the circle, not inside the circle, on the circumference of the circle, has to fit the equation. In other words, when I had a radius of 2, and my equation was x squared plus y squared equals 4, no matter where I'm at on that circle, if I'm at this point right there, well, what is that point? That point is 2, 0, right? That means I should be able to plug in 2 for x and 0 for y, and it should still be an equation. And it is. If I'm down here on this circle, if I'm on the circumference, but down here, say, well, what is that point? That point is square root of 2 over 2, comma, square root of 2 over 2. Plus and minus. How do I know? Well, if I put the x point into that, I get 2/4. If I put the y point into that, all right, I made a mistake. That point is actually square root of 2, not divided by 2, and that point's minus square root of 2. In other words, I know this point is on the circle because when I put these two values in, I still have an equation. I get 2 plus 2 equals 4. So if a point is not on the circle, it is not going to satisfy that equation. And they will maybe give you a question that says something to the effect of which of the following points are on the circle. Well, you have to kind of plug in all the points they give you into the equation of that circle and see if each one of them still leave an equation. Same thing with this circle down here. If I gave you a point right there. For that point to be on that circle has to satisfy. Whatever the x and y coordinate of that point is, I can plug it into this formula, and it better still be an equation. Otherwise, that point is not on the circumference of that circle.
Okay.
Okay? That's circles. That's all you need to know about circles. The only other conic section you need to know about, and you'll probably get one question on circles and one question on ellipses. So you need the general formula for the equation of an ellipse. Not that dissimilar to circles. Only it's got this a squared and b squared under it, and instead of equaling the r squared, it's equal to 1. Now, why is that? Because an ellipse has a major radius, that you could call that, and a minor radius, which you could call this measurement. That's your A and your B. In other words, this is A, that's B.
Okay.
So if this ellipse it was 3 from the center to that vertex, and if it was 2 from the center to that vertex, then the equation of that ellipse would be x squared over 9 plus y squared over 4 equals 1. That equation right there is that ellipse. And the same reasoning goes. If there is a point on the circumference of the ellipse, whatever the coordinates of that point are has to fit that equation. In other words, if I said, is the point 10, 10 on that ellipse? Well, the answer is obviously no, because 10 squared is 100 over 9 plus 100 over 4. That does not equal 1. So the point 10, 10 could not be on that ellipse.
Okay.
Okay? Now, one last thing with the ellipse. This is the general format of the equation if the center is at the origin. Just like a circle, if it's not at the origin, we have to add a minus h to the thing, where h is the x-coordinate of the center and k is the y-coordinate of the center. Still equal to 1. So, if I had the following equation, x minus 3 squared over 4 plus y minus plus 1 squared over 9. Switch these, make this 9 and this 4. If I gave you that equation of an ellipse, I can graph that starting at the center. Where's the center? What's h equal to?
H is negative. Wait, I'm kind of confused on this.
Always x minus h, no matter what you're doing. It's like translations.
Right.
You always have an x minus h. So h is what?
Well, I don't get what, there is nothing on the graph.
Hold on, that's because we haven't graphed it yet. We're not going to be able to graph it until you tell me where the center is. In other words, for me to graph this, I need to start with where the center is. So we get the center by finding h and k. In other words, here's the general format.
Yeah.
H is the x-coordinate of the center. K is the y-coordinate of the center. So in this specific equation, what is H?
Oh, well, H is -3.
Positive 3.
Positive 3?
Look at it again. It's
Oh,
x
'cause it's
minus
squared.
H. So H is positive 3. What is K?
K is 1.
Negative 1. Remember that it's y minus K. If K was positive 1, it would be y minus 1. It's not. It's y plus 1. Therefore, K has to be minus 1 because we would have y
Okay.
minus a minus 1.
Okay,
That would give us y plus 1. So basically, your point is the opposite of whatever the sign is. So in order to graph this ellipse, I'm going to go to the center. Well, the center is right there. That's 3 comma minus 1. Now, I need to know what A and B are. Well, A is the long radius. That's from there to there. What's A?
A is
Remember, that's A
9.
squared. That's A squared. So A is 3.
Oh, A is 3.
And
Okay.
B, this is B squared.
Right. So then it's 2.
Okay, and there's the graph of it. And that's all I need. For an ellipse, all you need to know is where the center is, where each of your major vertices are, and where your minor vertices are. Now, you'll learn a lot more than that when you study conic sections, but for the ACT test, that's all you need to know, is what I just told you about ellipses and circles. And the most important part is the general formula. That is the general formula of an ellipse.
Okay.
That is the general formula for a circle. So if you want to memorize anything, memorize those two things and know what they mean. In other words, know what the H means, know what the K means, know what the R means. Know what the A means and know what the B means and the H and the K.
All right.
Okay? So that's a pretty good primer on the ACT versus the SAT. You would not have needed to know any of that trig or any of this conic sections for the SAT. Not to say that the ACT is harder. I don't believe it is. If you eliminate the trig and the conic sections, I think the ACT math questions are generally easier than the SAT.
Yeah. Could we do a couple examples or
Sure.
just sample problems?
Absolutely. You want
Yeah,
ACT?
because I remember when I took the plan test, which is the practice ACT, it was definitely a lot easier than the PSAT.
Yeah.
So hopefully that's still applies.
Question 1. This is ACT. Notice what else they don't give you. On SAT, they give you all those formulas and geometry. In other words, they give you a triangle with the area of a triangle. They give you a rectangle, the area of a rectangle, and so forth and so on. ACT doesn't give you any of that. You have to know all of that.
Okay.
So, solve for X.
Okay, let's see. 2x. Okay, well, I have -5 from both sides.
Okay.
And then divide by 2, so it's 6.
Correct. Okay, how about number 2? Bit of an unusual. It's a logic statement.
all horses that run fast are brown. Horse A is not brown. Horse B runs fast. Horse B is brown. G.
Correct. Correct.
That doesn't even seem like math.
Well, it's geometry. If you remember your geometry, you start out with if P then Q does not mean if Q then P. In other words, it's a logic, and they don't do a whole lot of logic on this. But if I say if P then Q, the only thing I know for sure is if not Q, then not P. An example would be is if you live in Colorado, then you live in the United States, right?
Mm-hmm.
Does not mean if you live in the United States, you live in Colorado. But it does mean that if you don't live in the United States, you do not live in Colorado.
Okay.
So that's the basic logic. This is all you have to know for any kind of logic questions. Is just make sure that you don't assume that if Q then P, which most people usually do. That's the biggest mistake people make on logic problems, is they assume that if A then B means if B then A also.
Okay.
Okay. Number 4.
Number 4. And can you use a calculator on this? Do you know?
Yes, you can.
Okay.
Although, I don't know if you've watched the news in the last couple days, they are changing the SAT test.
Yeah, I noticed that.
They're removing the essay, so it's going to be a perfect score of 1,600 again instead of 2,400. Mm-hmm. And they're also going to have non-calculator sections on there, which personally I think is a good thing.
Yeah, I was hearing about it. It's less, like it's less about getting a tutor. It's more like just your.
Well, it means you can't be. It means you can't be 100% dependent on your calculator. You've got to be able to do some calculations by hand. Now, they're not probably going to ask you to do something like this by hand, but they will expect you to do single-digit and double-digit stuff by hand. They would expect you to be able to do that. But I don't think those changes are going into effect until 2016. Yeah, so in all likelihood, you'll take the old SAT test where you'll have to write the essay and you'll be able to use your calculator for the whole thing. You don't have a Inspire, do you?
No, I have an 84.
Okay, they'll let you use that for all of it. If you had the Inspire CX, that has such good capabilities of it that they won't let you use that whole thing on the tests.
Yeah.
That'll do factoring and everything. So this is actually a very simple question. Don't be fooled by the fact that it looks like a complicated word problem. It isn't. All they're saying is a of b, a function, is equal to 4b minus 30. So what happens when you plug in 15 for b? How much do you raise? A of b is the amount you would sell or raise by selling b boxes of cookies or greeting cards. So what would A of 15 be?
Let's see. So that would equal 30 or 60 minus 30.
Correct. That's the answer.
30.
Uh-huh.
Okay.
They do get a little harder as you go on. It's mainly algebra and geometry. And I don't know if I know exactly where a trig function is, but we'll come across it eventually.
A carton of 12 cans of soda is priced at $6.60. The soda goes on sale for 20%. What would be the price of the carton? Um, 12% or 20% of 660.
Okay. So that's your first step. You're going to take 20% of 660.
Mm-hmm.
Okay, that is 320. Excuse me, that is not 320. I can't do math all of a sudden. That is $1.32. So what's the price of the 12 cans of soda going to be?
Wait, how did you get the $1.32?
By multiplying 0.2, which is 20%, times 660. In other words, this is the discount. $1.32 is the discount.
Right, so that's 660 minus that discount.
Which gives you 528.
Okay. Yeah.
Notice that 12 had nothing to do with anything.
Yeah.
They will frequently put irrelevant information into the problems. So don't assume that just because you see a number in there that it's part of the answer or part of the figuring.
Okay.
Now, there's a little easier way to do this problem. We did it in 2 steps. First, we found out the size of the discount, and then we subtracted it from the list price. But it turns out that it's easier really to do it in 1 step. If I multiply it by 1 minus 0.2, I'm going to get the exact price immediately. And since you're using your calculator, 1 is always better than 2 steps. You see why I can multiply the price by 80%? If I take 20% off of a price, that means I'm going to charge you 80%.
Okay, yeah.
Okay?
Mm-hmm.
If I had a 5% sales tax on this, let's say instead of discounting it, I'm going to charge a 5% tax. Well, I could do it in 2 steps by figuring out the tax and then adding it to the 660. But the easier way is to multiply the whole thing by 1.05. That will give me the final price with the tax. So when you're adding percents to a price, you add it to 1. When you are discounting a price by a certain percent, you can multiply it by 1 minus that.
Okay.
So 25% discount equals 75% of the price. A 10% tax means I got to multiply the price by 1.1. Okay, here's a good one. A squared equals 64, B squared equals 81. Which of the following 5 numbers cannot be the value of A plus B? Well, tell me what A is.
It's 8.
It's actually plus or minus 8. Whenever you're solving an equation by taking the square root of both sides, make sure the first words out of your mouth are plus or minus. Everybody forgets it. Everybody does, including me. But if you forget it, you're going to mess up on these problems. What's B?
Plus or minus 9.
Okay, so now we have a lot of things that A plus B could be. If A plus B could be minus 17 because A could be minus 8 and B could be minus 9. It could be minus 1 because B could be minus 9 and A could be plus 8. What number can it not be?
let's see. Well, it can't be 145.
Exactly. And one lesson to be learned here is that they will frequently make these problems very easy by putting a ridiculous answer on there.
Yeah.
In other words, you didn't even need to check 1 or 17. You knew that there was no way you're going to get this number. So you can actually answer it immediately without even knowing all this stuff. So always kind of look for the ridiculous answer on there. And a lot of times they will put such a wide margin between answers that you don't even have to do the math. You can figure it out just by looking at it. Let's do one more. We got a couple minutes, and this is a geometry one. And since a good part of the test is geometry, let's do at least one geometry here tonight. So we got the line AC is parallel to DG. What is the measure of this angle right here?
Let's see. I remember.
There's one principle that is huge on both tests, and it is parallel lines with a transversal. Whenever you have a transversal that cuts two parallel lines, you create two angles, A and B, that are supplementary to one another. They have to add to 180. And every other angle you're looking at is either A or B. That's A because it's the big one. That's B because it's the little one. That's got to be A, it's the big one. That's got to be B, it's the little one. That's B because it's vertical. That's A because it's vertical.
Oh, okay.
So
yeah,
this is what you remember. You need to remember that right there. There will be at least 4 problems on this test that require you to know what happens when you cut two parallel lines with a transversal. So if that's 40 degrees, that's the small angle, right?
Mm-hmm.
This angle, without this line, the only reason they stick this line in here is to confuse you. What is this angle right here?
That angle is 40.
Okay, what's that angle?
And that angle is 140.
Exactly. This is the big angle, that's the small angle, and they're always supplementary.
Okay. Yeah, that line definitely...
They always throw that line in there. So always you need to be able to kind of remove it visually. Although not really, because even without that line, you can know that this is 40, always. The inside ones, the small inside ones are always the same. And once you know that's 40, you know that's 140. But there will be problems where they'll throw in a lot of extra lines, and you really almost have to be able to visually take them out and analyze it. In other words, you can't see me covering that line up, but put your hand over that line and see if you can analyze the problem with just the two parallel lines and the transversal.
Right.
All right.
Okay.
That's a good place to stop. All right, Thomas. Okay. Have a good week, and I will talk to you next time.
All right. Sounds good. Thank you.
All right.